In this video, we're going to discuss some probability rules, and the first rule is fundamental counting. What this rule is doing is it's going to be using the rules to determine the total number of possibilities in a sequence of events. And what we're talking about here is, think about if we want one thing to happen and then another thing to happen, and we have possible options for those things, and we want to know, well, how many different ways can this happen? And so this is the fundamental counting rule. And what we're going to do is we're going to multiply the possibilities together. So you take how many ways the first option is possible times how many ways the second way is possible, and just keep multiplying them. The formula for a fundamental counting rule looks like this: how many ways the first option is possible times how many ways the second one is possible times how many ways the third one is possible, and you keep doing that up until you get to the final number of ways, or the final item that you're looking at. How many ways is it possible? And we multiply these. Let's look at an example. We want to look at a restaurant is looking at their menu and trying to determine the number of meal combinations that can be made. Their current choices include appetizers, which is fried cheese, chips with dip, onion rings, cheese fries, potato skins, and nachos. So there's 6 different appetizers. For salad choices, you have Caesar or House, so you have 2 different options for salads. For your entree, you have grilled chicken, steak, shrimp, smoked ribs, salmon, catfish, chicken tenders, and pot roast. So there's 8 different possibilities for your entree. For your sides, you have the possibilities of broccoli, corn, carrots, coleslaw, fries, mashed potatoes, green beans, red beans, okra, and soup. So there's actually 10 different possible sides. And then for desserts, we have apple pie, fudge cake sundae, a cookie, milkshake, cheesecake, or ice cream. And so there's 6 different ways, or 6 different possible desserts. If a person goes to this restaurant and selects one item from each category, how many combinations can be made? And so what we're going to do is we're going to say there are 6 appetizers, 2 salads, 8 entrees, 10 sides, and 6 desserts. We're going to take those and we're going to multiply them. So if I look at my appetizers, my salads, my entrees, my sides, and my desserts, I've got 6 appetizers, 2 salads, 8 entrees, 10 sides, and 6 desserts. And I'm going to multiply these, which that will give me 5,760 different possible combinations, because I could choose fried cheese, Caesar salad, grilled chicken, broccoli, and an apple pie, or I could choose fried cheese, Caesar salad, grilled chicken, broccoli, and a fudge cake sundae. And right there's 2 options, and I haven't even changed the appetizers that I'm looking at. And so we have all these different combinations. When you're taking one item from each category, we're going to use the fundamental counting rule. Now what we're going to look at is factorial notation. Factorial notation uses the exclamation point. It uses the exclamation point. And what this actually represents is when we have 4 factorial, that is written 4 factorial. What that means is I take that number and multiply it by the numbers below it, and I guess I need to put a 3 in there, don't I? So that's 4 times 3 times 2 times 1. It goes down to 1. It's multiplied by everything to 1. And so 4 times 3 is 12, times 2 is 24, times 1 is 24. So 4 factorial is 24. I do this with any of them. Even if I have 8 factorial, I start with the number I'm given, 8, and I go everything between there and 1. So I say 8 times 7 times 6 times 5 times 4, 3, 2, 1. Multiply those out, and that gives me 40,320. The one that we have to be careful about is 0 factorial. 0 factorial is 1 because we're multiplying things down to 1, and 0 is actually below 1, so we just multiply 1. So 0 factorial is going to be 1. This one's going to be one of those rules that you want to just kind of remember, okay? We're going to use factorial notation in several items throughout the rest of this video, so you definitely want to make sure that you know it. There is different calculators that will do factorial notation for you, figure out the factorials for you, and if you need help with that, that's fine. Let someone know and we'll be glad to help you. One thing that we're going to look at also is what we call permutations. Permutations is the arrangement of objects in a specific order. So we have to make sure that we're doing it in a specific order. Permutations, we're taking so many items from a group of items. Order is going to matter, or we're going to look at with replacement. We're putting things back. So permutations, order matters, and this is with replacement. The formula for this is going to look like this. NPR is equal to n factorial divided by n minus r, and that quantity factorial. N is the total number of objects that you have. So the total number that you have. R is the number that you're arranging or that you're choosing. Okay? So your N is always going to be equal to or larger than your R. You can never have an R that's larger than your N. So be careful about that. Let's look at an example. You have space on your wall for 3 photos. When you look, you have 8 to select from. How many ways can you arrange 3 photos on your wall from the 8 you have? Okay, so we know that we have 8, and we're going to select 3. Well, since we're arranging them on the wall, order is going to matter because I can put them in place like this, or I can place them like this. There's multiple ways that I can put them up on the wall. And so how many we have is going to be our N, and how many we select is going to be our R. So remember, my formula looks like this. And so whenever I actually start plugging in my numbers, it's going to be 8 P3 is equal to 8 factorial over 8 minus 3 factorial. Where I simplify that down, that's going to be 8 factorial over 5 factorial. Okay, well, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5, 4, 3, 2, 1. And whenever I look at this, my 1's can cancel out, my 2's can cancel out, 3's can cancel out, 4's can cancel out, 5's can cancel out, which is going to leave me with 8 times 7 times 6, which whenever I multiply that out is going to give me 336 ways. So to answer my question, there are 336 ways to place 3 photos on your wall out of the 8. And we're really going to be looking at things, can you break this down? Some of your calculators will also do the permutations and the next step, the combinations, but make sure that you can do these by hand as well. Okay? So this was permutations where order is going to matter. The next one is combinations. In combinations, this is the selection of objects without regard to order. So order is not going to matter here. Okay? The formula for this is going to be NCR. Notice we use P for permutations. Now we're going to use C for combinations. And it's going to be N factorial over N minus R factorial. Let me get this looking right. So let's see here. N factorial over N minus R factorial times R factorial. So we've got this extra added R factorial in the denominator. So it's going to make our number actually smaller because we are dividing by more. Let's see how this is going to work. So there are 13 movies on my shelf. My sister and I have time to watch 5 of them. How many combinations can be created by selecting 5 movies from the 13? Now, does it matter what order we watch the movies in? No, because we're just going to watch these movies. So, order does not matter. We have 13 movies. we're going to watch 5 movies. So this is my N and this is my R. So whenever I start putting it into the formula, it's going to be 13 choose 5. So it's going to look like 13 factorial over 13 minus 5 factorial times 5 factorial. Whenever I simplify this, it's going to be 13 factorial over 8 factorial times 5 factorial. So that's going to be 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we have 8 times 7 times 6 times 5 times 4, 3, 2, 1. And the 5 factorial, which is 5, 4, 3, 2, and 1. Not 5, 1. Okay? And then I can begin crossing them out. 8s cancel, 7s cancel, 6s and 5s, 4, 3, 2, and the 1, which will leave me with 13 times 12 times 11 times 10 times 9 over 5 times 4 times 3 times 2 times 1. When I do this multiplication and then the division, this is going to give me 1287. So there are 1,287 different ways my sister and I can watch the movies. So there are 1,287 ways we can watch 5 movies. Okay? You have to be able to pick out whether it's going to be a combination or a permutation, and that's going to be your biggest key. Here are the rules in a summary type format. We first have the fundamental counting rule. That's just the number of ways a sequence of events can occur. And this is our K1 times K2 times K3. We're just going to multiply them. Permutation is the number of ways n objects can be taken at a time. Order matters, and it's with replacement. This is going to be n PR, which is going to be n factorial over n minus r factorial. And then combinations, order is not going to matter, and it's without replacement. That's n CR, which is going to be n factorial over n minus r factorial times r factorial. If you have questions, please let me know and we'll go over it.